Don't touch it.
Don't touch the tripod.
Okay. 103 was easy. 110, all we did was we took the formula and said the derivative of negative h of x was negative h prime of x, plugged in the 2, looked at our directions, right? For 112, we simply used the derivative of a product, or the product rule, derivative of the first times the second, plus derivative of the second times the first, and then plugged in our 2's and found them in the directions. 116 and 118. All right, 116 was that graph, wasn't it?
Yeah.
And essentially, it looked like a cubic thing, didn't it?
Yeah.
At -1 or
Yeah.
-2, because each of those dashes was 2. Yeah. So if we are drawing the derivative of that, I know I didn't draw it very well, but it's not an exact science, right? Yes, it is in general, but so we are sketching the graph of f prime. So put our little pencils here. What are the slopes? F prime means the slope of the tangent. So the slopes are all really steep positive, coming down maybe 1 right there. Throwing in a 1 right there, pretending that's 2. Then we come really close to 0. So really steep positive, close to 0. And we go back positive again, don't we? On the right side. So that's my rendition of f prime. Parabola, yeah. And then the derivative of a parabola would be a straight line, and that looks almost vertical, but steep negative, not so steep negative, to 0, then goes positive. There's my rendition of f prime. I mean f double prime. Is it an exact science? Well, my angle line, I mean, as long as it goes from negative to positive, we're good. Whether it's going to be sloped this way a little bit more or a little more vertical.
So F triple prime would just be a line. So
F triple prime would be probably a line up this way. Yeah.
What would F quadruple prime be?
0.
They'd all be zeros. Yeah. You'd have, for the 5th, 6th, 7th, 8th, 9th derivative, they would all be horizontal lines.
So, as a general kind of rule thing, it goes down in the power.
Yeah, because what do we do for the derivative rules?
down the power.
You take the power down in front and lower the power by 1. So the derivative of a quadratic would be a line, or the derivative of a cubic would be a quadratic.
But the zeros all have to be at the same place.
The zeros are the points that I would be looking for, you know. Looks like a cosine function that's been moved up for 118.
Yeah. And then double derivative.
So this is sine, this should be cosine.
And then you flip it.
Cosine, and then
Yeah, negative sign. Negative sign.
Is it still recording?
To pause.
I'm very concerned about this.
How much?
So it really just looks like a cosine function that's been moved up, right? How many units has it been translated up?
1. No,
2 units?
Yeah.
Okay. But again, Joanne said that the derivative of a cosine will end up being like a sine function, right?
Negative sign.
Well, or a negative sign, yeah. Derivative here is, what's the slope of it?
It'd be
0.
negative 0.
What's the derivative here?
Zero.
0. What's the derivative here? 0. So we know where our zeros are. And now look between. They're negative. Negative. Right here in the middle is probably about a negative 1. Back to 0. Right in the middle there is probably a positive 1. And so we illustrate that even though that cosine function has been translated up to units, when you say, if you call that the cosine of x plus 2, what's the derivative of the 2? 0. So it just comes back to an vertical shifted sine or negative sine function. Do we have to do the second derivative? Okay, then the derivative of negative sine, well, our zeros are here. We think it's going to be negative cosine, right?
Just sine. Negative one.
Negative cosine, that'll be a negative 1. That will be positive 1.
Oh, no, it's not.
Yeah.
Never mind. It looks like almost.
So we have right here
Yeah.
y prime, right here y double prime or f double prime, whatever they called it. F double prime.
Yeah.
Alrighty. Feel good about those?
Yeah.
Alright, page 162.
Still recording.
It is still recording. Thank you so much.
Javon doesn't want anything that can be used against
Is it
him.
hard to write like that?
A little bit.
Is it hard to write through a tripod?
A little bit.
I don't know. Let's find out.
No, not through. Technically, I'm not gonna say it. So
It's focusing on this.
it might be dumb.
You gotta
Great.
be careful about what you say.
Alright, gotta take this out for a second. Let it focus on my hand.
You know, I bet the projector thing probably has a record function.
What's the things on the
Not
side?
this one. This one's analog.
Yeah.
It wouldn't even
pretty
record
old.
digitally at all. Alright,
You can plug it
number
out to a laptop if it's screen.
162. This is finding, determining horizontal tangent lines. Is that
Page
correct?
162. It's page 162.
Page 162, not problem 162. Whatever.
I was gonna say it.
And the numbers were
127.
127,
1.
129,
135.
131, 35, 37. I'm writing so neatly. 139 and 168. I knew there was a 161. All right,
There's
What did I do?
127. Y equals 2 tangent cubed x. How should I even write this down?
You should do as a blob.
As a blob cubed, correct?
yeah.
That's what I did.
When you take the cube.
We are finding the equation of the tangent line, right?
Yes.
So, this is pure chain rule, isn't it?
Blob
Power down in front,
6
6.
tangent
Leave the tangent alone.
x.
Lower the
squared
power by 1.
Secant squared x.
Secant squared x. Go straight to plugging in a pi over 4. Tangent of pi over 4, y'all, is
Is 1.
1. Secant
Is
of
1.
pi over 4.
It's also 1.
No,
Oh wait,
it's
no,
not.
it's pi over. 1 over root 2.
Yeah.
No, root 2 over 1.
We could go,
Wait.
yeah, 1 root 2.
So then it's 2.
So it's the square root of 2, but the square root of 2 squared is 2 times 6 would be 12.
12.
So, they didn't have that as the slope?
I'll look it up. Wrong book.
29 along. So then when you,
No,
whenever 123 you got the same answer.
You got 8 over 5 for 123?
Yeah.
That was right.
I'm like, I thought it would have way
No,
more
they did.
sugar.
Yes, they put it in standard form. I tried to tell you. It is this. All right, look at 120. Look at the answer. What answer did you get for 123?
123.
8 over 5 as a
Minus
slope.
5y minus 7 equals 0. Or
Yeah.
whatever equivalent.
Y minus 5 equals, what was the slope? 8 over 5, you said? Or was it 5 over 8?
8 over
8
5.
over
8 over
5.
5.
X minus 4. The
Yeah.
back of the book did not put it this way, and they didn't even put it
Move it up.
as a, they didn't even put it as a regular slope-intercept form, right? So what we do, multiply both sides by 5.
Why don't we just leave it as line?
I want it like this. This is how I want it. But if you're afraid that you did not get the right answer because of the back of the book, this is what I'm showing you.
That's what it gave?
No,
No.
they then
It gave
subtracted
general
the 5y, added the 25, and what did they get?
Minus 7.
Equals 0. That's what the book gave. It is the same exact answer. They are equivalent.
Where's the AP exam?
As far as I know, I've seen them in all forms. I've seen this one. I've seen y equals 8/5 x minus 32/5 plus 25/5 7/5.
Yeah.
I've seen it in that form.
I'm confused. What is the point of general form?
Pardon?
What is the point of general form?
What's general?
That
You
The
mean,
8x minus 5y.
I have no idea.
That's
And that's not really even standard usually has the C on that side. So this might be called general form. I have no idea.
it's SSF, stupid standard form.
Stupid standard
For
form.
free response, the first
It's-
one.
it's-
we just
it's
were-
Free
opposite of
response,
SFS.
stop. Stop, stop, stop. Or here.
Yeah.
Whichever form. Stop. Can I say it again? Stop.
Can you spell it, Paul?
S-T-O-P. Sometimes I can
Cameras always
spell
have
it.
phrases, don't say stop.
P-O-T-N. Bots.
The camera will.
Camera
That's funny.
Wait, is this still recording?
It is still
Oh my
recording.
god, you're fine, chill.
Alrighty.
I'm done.
So, same thing. What's the derivative?
It's 2.
Negative 2x.
Negative 2x.
U prime over u right here. Blob prime over blob is the derivative of natural log blob.
Yeah.
Now, I know that you officially could go straight to a plug-in here. And maybe we should, since we're plugging in a 0, right? Negative 0 minus 1/2 over 0 plus 1. 1/2 over 1 is, so what is, yeah, it is negative. Our equation is y minus 4 equals slope x minus 0 and stop.
Yay.
Oh, that's the issue. It is still. There we go.
It's a tissue issue.
It's a tissue. Oh, good heavens. Can I fit 131 down here?
Probably.
Oh, yeah. 4 to the x.
X.
That's the obscure formula. It's like e to the x. So the derivative is just the same. 4 to the x. Derivative of x is 1. Throw in the ln 4 and you're done.
Oh wait,
What?
I tried changing when I put x times 4 to the x minus 1.
You
for
would be
those of you-
incorrect.
Okay.
For those of you
Wait,
watching
okay,
this who can't see, Miss Washington just shook her head for a good 30 seconds.
Wait, let me write this down.
This is the obscure rule. Guys, an x in the exponent will never be a pull down in front and lower the power by 1. It simply will not be that. Okay? So, anything other than the x in the base, an e or some other constant, it's the new rule.
Why is it, when you give me ln, shouldn't you pull the exponent down in front? No? Just ignore it?
Still shake your head.
The derivative of e to the u is e to the same u, no changing it, times u prime. The derivative of a to the u is a to the same blob, blob prime, throw in natural log of a. That's the
Oh,
formula.
just the natural, oh.
That's the formula.
It's in the front of the board, too.
I did something really weird where I didn't use that rule, but I got the answer.
Same.
I just did the ln of both sides. And then
Okay, but that would be, that's implicit differentiation. We do have a thing called logarithmic differentiation where you take the log of both sides. But how did you deal with the log of, the natural log of y
I just
on the left side?
Just
I
forgot about it.
multiplied it by. So like. I don't know. It was really weird. So like the
How did you get the 4 to the x?
I plugged it back in.
Well, you were really, really close because that you happened upon logarithmic differentiation. The problem is you have to tack on. If this had been like an x squared, you probably would have gotten it wrong.
So
But-
what is A in that?
4,
4.
Okay.
the base. All
I
right,
don't think this will work.
Yeah.
131. 135.
Step outside.
Sure.
Why?
No.
You don't want your beautiful trumpets to show off.
G of t is, can somebody read it to me?
T squared times 2 to the
T squared
times 2 to the e.
times 2 to the t. Practice our formula again, right? Derivative of the first times the second. Leave it alone. Plus derivative of the second. A to the u. A to the same u. Derivative of u is a 1, right? Natural log of 2. All of that is derivative of the second times the first. And I'm seeing a 2t that's in both of them. And a t that's in both of them.
Like that one.
2 plus